All right, guys. In today's lesson, we will be solving cubic equations. Um, so we have started the lesson. So we've discussed through this last time where we can find solution of the equation if it's in this factorized form. So when I say factorized form, we are talking about your linear. So the quadratic equation or the cubic equation would be in its linear factor form, pretty much. So you can see the first one is in factorized form. It is x minus 2. It's in brackets. So when I say factorized form, it's brackets form. So we equate the equation and then we try to solve for it. Now, when it's in like a polynomial form, then you factorize using inspection method, or you use the other methods of factorization and find the solutions for x. Now, when a cubic equation is in factorized form, how do we solve it? Now, it's in factorized form, so we are just substituting each of the factor to 0. So the first factor is x equals to 0, x plus 3 equals to 0, and 2x minus 5 equals to 0. And this is called null factor law because it's in factorized form and each of the factor is equal to 0. X equals to 0, x equals to negative 3, and x equals to 5 over 2. So these are the three x-intercepts. Because it's a cubic equation, the graph going to cut at 3 spots. Now the next part is, so this is our first answer. So the solution would be x equals to 0, 3, and 5 over 2. Now the next part is 2x minus 1, x minus 3. So again, we do the same thing. It's in factorized form. So equating each factor to 0. X minus 3 equals to 0. 3x plus 2 equals to 0. And that would be x equals to 1 over 2, moving 1 to the other side and then dividing by 2. X equals to 3, and x equal to negative 2 over 3. Now for this one, x minus 4 squared and x minus 6, again, the same thing now. It's the x minus 4 squared can be rewritten as x minus 4, x minus 4, and x minus 6. So you will see there will be two same solutions. So it would be x equals to 4, x equals to another 4, and positive 6. So when it's a perfect square, one of the factor is perfect square. So you will end up getting the similar values. So this is the solution. Now, here, looking at the cubic equation, we can take out a common factor and we'll end up getting some sort of common factor like grouping. So let's say if I take out common factor for the first, so we can see x is common in all of the, for the entire equation. I'm going to take out x, and then that gives me 2x squared minus x minus 1. And that gives me a quadratic equation to solve for x. Then use the simple method of factorization again. So it's 2x squared. So we need to find the factor of negative 2. That gives me negative 1. Factors of negative 2, when you add or subtract, that gives you negative 1. So negative 2 plus 1. So, and that when you multiply, that gives you negative. So negative 2x plus x minus 1. And we'll try to factorize x to x, x minus 1 plus 1, x minus 1. And that gives me three factors, 2x plus 1 and x minus 1. And then you solve for x, and that would be x equals to 0, x equals to, because we are putting all the three factors equating to 0, x equals to negative 1 over 2, and x equals to 1. So this is another example from exercise 60. So we are taking out the common factor. You can see all the three terms have x. So I can pull out that x, and then that leaves me x squared plus 2x minus 10 equals to 0. And then you factorize. So two factors of negative 10, that gives you negative positive 2. So two factors of negative 10 could be 5 and two other two factors. I need to keep 5 positive and 2 negative because I need positive 2. Okay, now that doesn't work. 5 and 2 does make 10, but doesn't give you 2 as the middle term. So what can we do here? So if it was 3x, then that would be the possible game, but we cannot. Now what we can do is we use other methods like quadratic formula or completing the square method. I'm going to use completing the square method, or I'll just use quadratic formula, whichever you think is easy. You can solve for x. Hang on. So completing the square method is, I'm going to do x squared plus 2x minus plus 2 over 2 square minus 2 over 2 square minus 10 equals to 0. Don't forget there is an x outside. So that gives me x plus 1 whole square. This whole part becomes, and then we have minus 1 minus 10. And that becomes x x plus 1 whole square minus 11 equals to 0. Now we know we need to solve. So we need to solve for this one, this part as well. So what we do is, the next part of completing the square method is we try to bring it to difference of square. So I'm gonna rewrite 11 as square root of 11 square. And then we can equate this part to 0 and solve and factorize. So one of the three factors would be x equals to 0. And then I have x plus 1 square minus root 11 square equals to 0. Now, if you remember your, the difference of perfect square rule, that would be x plus 1 equals x plus 1 equals to root 11. I mean, x plus 1 plus root 11 equals to 0, and x plus 1 minus root 11 to 0. It's a square minus b square. So a plus b, a minus b. And that will give you x equals to 1 plus or minus root 11. So you will have two solutions, 1 plus root 11, 1 minus root 11, and then you have x equals to 0. Solution is on the next page as well. So you can see the working out. So cannot use the inspection method, and then we use solve for x. How we use grouping. So when you look at the polynomial, you need to figure out which method would be more suitable. Shall I use the inspection method? Shall I take out the x and then solve for x? Or I just use the grouping method to factorize. So here I can use grouping method. I can see, I can pull out something because there is some similarity between first group and second group. So let's see, if I take out x squared in the for the first two group, it becomes x minus 4 minus 11 x minus 4 equals to 0. So we have x squared minus 11 equals to 0. And then we have x minus 4. So I'll just minute, I'm gonna write as in factorized form first. So what we have here is x squared minus 11, and then you have x minus 4 equals to 0. So we can equate each factor to 0, and we get x squared equals to plus or minus root 11, square root of 11, and x equals to 4. So the three solutions would be x equals to square root of 11, negative root 11, and positive 4. By using trial and error method,